Kelly? Christopher? Darren? Darren Strong? Sarah? Benjamin? Benjamin? Ron? Ron? Charles? Peja Sai? Inama? Shiva? And Umesh? And Bharat? Okay, so there are several announcements. So today we are going to continue the lecture for the chapter 9. We are going to skip the 2 chapters regarding to the sequel. We will cover the sequel after we complete the chapter 9. So 9 and 8, so relationship. And most of the team complete the project piece 1, but piece 2 is regarding to the conceptual design, which is due on this week, Friday, right? The September 26th. We are not going to extend the due date from now on because we have a lot of things to do. So please start your conceptual design based on your piece 1. If you received any comment from the DBI, please address such a comment and the issues or the suggestion, and it's allowed. If you have something new idea or revise the project scope, which means your phase 1 can be changed. So anytime, if you need it during the project period, you can go back and change it. And when you submit it, please notify. So let us know that you are going to change the scope of the project and so on. Okay, requirement. So please do the conceptual design part getting to the phase 2. Then any homework assignment or take-home exam, please do your best to submit on time. So then you can catch up or the class work successfully. Also last week we did the AWS lab. It's optional, but even though you didn't attend the AWS lab on Friday, please study by yourself. So if you go to the AWS training, so there are material. So even the lecture, the video. So I couldn't cover all details of the AWS, the cloud foundation. So even though you attended the Friday lecture, please go over. If you have any question or the missing part, you can watch the video or you can read the tutorial. Also, there are, I think, some assessment. It's a very simple check of the content. So then, eventually, if you are interested to take the ACF exam, certification exam, I'm contacting the AWS to receive the voucher. They suggest each institution to support the cost of exam, but the UB does not. So I tried my best to get the discount voucher. So those who are interested to take the certificate exam, ACF, so pretty much before the midterm exam, I will inform you. Then you guys can set up your exam schedule online. It's also AWS training site. So if you click the certification, you need to sign in again with the official name, because that name will be used for the verification. Should be same as your ID and so on. I will inform you when I receive the voucher. Any question relating to the announcement? Our midterm exam probably after the exam period. Okay, so midterm exam period probably I think the middle of October this week, but we need a couple of more weeks to cover the SQL, at least the SQL and the programming part. So probably we will have the midterm exam October 21st or the 23rd. I'm going to confirm the date of our midterm exam. Meanwhile, So because we already did the AWS lab, or if you don't attend the AWS lab, you guys can do by yourself. So we are going to have the exercise lab with the MySQL database. It's up to you. If you want to use the MySQL on AWS, you can use. Or you can use the MySQL with the GCP. Either way is fine, but you should use the MySQL on cloud computing, not local machine. But for your training purpose, you can install, but you don't have to install because right now you are able to connect the MySQL database on the cloud, so you don't have to waste the space or the computation when you install such a MySQL. So it create a lot of process and service and so on. So sometimes it's not easy to clean up everything. So you guys can use the MySQL database, either the GCP or the AWS. So please, we are not going to show the details how to connect because you already know. As long as you have the MySQL client, it's exactly the same thing. Okay? If you don't understand what I'm saying right now, please try. So to create the MySQL database, GCP or MySQL database on the AWS. So then you can select either of them for your project. Okay? Either way is fine. So I'd like to see the student who want to use the AWS because eventually I'd like to change the computing environment for the AWS. Any questions? Correct. It's worthwhile, even though it's not directly related to the subject database. So we have the 6th lab on the vocabulary. So please try. How many labs did you complete?
3, Professor.
3.
We did DS also.
Yeah. So please complete the other labs. It's not easy, but mostly that is the really fundamental of the AWS. So like the setting up the VPC, setting up the IAM. So then you can create your subnet. Then finally you can create your EC2 or your database or the network balance and auto scaling, so on. Then on top of that, you can use the machine learning, the service or other services. Okay, so today, last week I was in a hurry to complete the relational database model. So let me quickly review what we have discussed last week. So that is a relational database model. So far, we talked about what is the information, what is the data. So our definition of the information and data is like that. So information is everything. So it's not organized, it's really information. I know some of the textbook mention about the information is defined as is important data. We try to extract the important information from the data, like the data mining or the machine learning. However, when we are talking about just information in this class, information is everything. Okay, like the information about him is he is always the nice and pay attention to the class. That's the information. But when we create the database for the student, we don't want to keep all the information. Instead, we try to keep some organized information and also important. Important means in terms of our requirement. To manage the student database for academic purpose, we don't need such the feeling or what kind of the clothes the teachers he wear. So instead, we try to keep something important and related information, ID, and something like that. To keep such the data, we are going to code such a data, and the group of data is called the database. To create the database, definitely we need to use the computer research, and then we are going to use the database management system. It's a software. This software is not just the software, it follows something model. So to make such a database from the information, first we need to do the conceptual, the database design, or data modeling. So it's called the data modeling, conceptual database design. So for that, we are going to use the ER model. So ER model actually the group does something information. So as an entity, and we have entity. Also we are going to find the relationship, and we have something the attribute, or sometimes we have the key attribute, something like this. Organized information. Okay, it's vague. It's really cloud like that, but this one is really organized, very close to the such a data and database, but still far. So to address that problem, we talk about the database model. Finally, we have the name of database modeling. So database modeling is we are going to define the relation. So each relation has a number of attributes or the number of instances, number of tuples. But each tuple should have the same attribute because it's kind of a standardization. Okay, so more strict standardization. And also we talk about something because it's a database modeling. So model means it's kind of a restriction or condition, constraint. So we talk about the key constraint, entity relationship constraint, and referential integrity constraint. It's like the foreign key layer. So these two define the primary key, this one define the foreign key. So that is the reason when we talk about the relational database model. So relational database, when you think about the relational database model, you always think of the primary key and foreign key because these two are the main constraint. So in other words, when you define such a relation, or eventually this is called a table. In formal terminology, it's called a table. Table should have primary key, and also if you have the multiple relation, there might be foreign key, referential integrity constraint. And plus, then we have more constraint, like for example, non-null constraint, and the user-defined constraint. Some of the customized, the constraint can be implemented by trigger, and so on. So most of the relational database members are that. So this one is called the relational database modeling. Dr. Lee proposed this one, 1969, and published in the 1970, and still being used. Then some of the vendors, some of the developers, developed the software used in the computer system based on this model. So this is called the relational database management system. For example, Oracle, Informix, DB2, Sybase, MySQL, MariaDB. Even Aura is a relational database management system, and so on. So at least it's more than 1,000. Even in this class, a long time before, so when I offered the separate the undergraduate database design and the graduate level database design, during the graduate level the database design, one of the project was developing relational database management system. So UBDB like that. I will show you later. So such a thing. Not fully implemented, the very basic, like the key constraint. Even we don't implement the foreign key yet. So the student implement the block-based, file-based, such as the relational database management system, like the really a lot. But we are going to use the MySQL database. So if you are using the MySQL database as a software, it doesn't matter whether this MySQL is on the Google or the My Laptop and even the anywhere. So as long as we have the client of the MySQL client, then we are able to connect the database. Then you can practice the SQL. SQL is the language when we have the relational model like that. So we can create the database using SQL. So later we will talk about the details about the SQL, but chapter 1 and 2 we talk about the data definition languages, data manipulation languages, some other. So data definition language is the SQL language to create the database. On the other hand, the data manipulation language is the update, delete, and insert of the data. Eventually you are going to select the data. It's a CRUD. So if you remind you're the data structure class, CRUD, the four operations are the create, the retrieve, read, CRU update, and delete are the four basic operations in the data structure. So this will be implemented in the SQL also. So using the SQL, finally we are able to create the database. This is called the physical database design. Physically, you are going to create. At this time, most of the DBMS support NC, the standard for the three schema architecture. Do you remember the three schema architecture? Conceptual level design, internal level design, and the external view of the schema. So our main focus of design, all this process focus on this one, conceptual level schema. However, we don't know how the database, the table is created inside the database, DBMS. Who is in charge of the internal schema? DBMS vendor. That's the reason we pay for the money, or the pay, then so it is simple. Otherwise, you need to know everything. That is the benefit of using the database system. External view, later we will see the relational database support the view. Okay. So in addition to this constraint, they support the view to create a different view of, it's called a virtual table. It's not real table, we have only one table, but we can create a virtual table. You will practice. So such the external view. Then, so and also we are going to mostly use the diagram. So ER diagram, and this is a relational schema diagram. I think I asked you guys to draw the relational schema diagram for the last page of this slide as your homework. Did you do that? So please submit before you leave. So this is the summary of the so far. I think that it's a fifth week. So fourth week, fifth week, like that. So it's a summary of what we have done so far. What we missed from the process of the database design. This is our goal, to create the database using the SQL. Next week we are going to talk about the SQL. Probably 2-3 weeks. So we will talk about this one. After we create this one from your application. So you are able to use, for example, the Java. From the Java, you are able to connect the database. You can implement the Java application. Or if you are using the Python, so I'd like to use the Python to connect the database. At that time, I'm going to use the web application server, for example, Django. So Django with the Python, this is an application server. So user can use the browser and connect your web server, application server, then the application server, and use as a data source, they are using the database, your database as a backend. Okay? So this is a database programming part. Everything will be done except this part. Actually, from the conceptual level design and the high level design, low level design, so there might be the gap between the ER diagram and relational schema diagram. Sometimes, if your database is simple, so you can directly draw the relational schema diagram, then create the database. That doesn't mean you don't need this one. Intuitively, you did. So when you are creating the database, having the more than 2,000 tables, 2,000 entities, then you cannot actually create all the table at once. So we need to draw such a relational schema diagram. So to do that, we need to convert this ER schema and to the relational schema diagram. So today we are going to see such a process, how to create the relational schema diagram from the ER model. Good news? It's just straightforward. We can just follow the step. As you can see, it's very similar. That is one of the reasons we select the ER modeling as a conceptual level modeling. There are different ways of the modeling, but we select the ER or the EER, the modeling, because there the model is very similar as a relational schema diagram. So we will see the step by step from the next chapter. So this was I don't have to explain this one. Please submit your answer, then the GA will correct this. It's kind of familiar with the notation. Okay, so this is a SQL. Yes. our goal is, this one is ER diagram, right? So for the company database, so we can see the entity, and relationship, and the attribute. We have the key attribute, the key, sometimes two key attributes, sometimes it's a partial key, and this is the weak entity identifying the relationship, and the self-reference one-to-one, one-to-many, many-to-many. This one shows the most of the popular, the concept of the ER diagram. Our goal is to change the ER diagram into the relational schema diagram. So this relational schema diagram is for the company database that we have used so far. You can see the employee table, the relation has the primary key, the social security number, and also the department has the D number as the primary key, and so on. Sometimes we can have the composite primary key, ESSN plus PNO is the primary key of the work zone, and so on. And also, you can see a lot of arrow. Arrow is the foreign key, okay? Referential integrity. So for example, the D number of the project, should exist in the D number of the department. That makes sense because when you have the project, that project should be controlled by the department. So department should exist. So how can we represent such a condition constraint using foreign key? Don't be confused the arrow. This is a referencing the D number, the D number. So reference is the head of arrow. Direction is important. So always, so is it true or false? Referenced attribute should be primary key. Yes or no? 99% yes, but not 100%. Candidate key also be the referenced one. Because what is a candidate key? So sometimes we may have the two candidate key. So social security number and UBID. But we can have only one as the primary key. So we select the UBID as a primary key. What about the social security number? It can be identified. So sometimes you can refer your social security number as the referenced one. It is okay. However, if not unique, there's no way which one is referred. So at least candidate key. Okay? So or unique. So that is the reference part. Then this one is our goal of the, yes?
Can the key that is referencing to a primary key be the same name, can have the same name as primary key?
So same name as the primary key?
Yeah, like D number and D num. What if both have the same name?
So the whole question is, what if we have the D number of this name? Is it okay or is it not allowed? It's okay anytime. Even you can create the A as the name of attribute. But as I said, when you create the name of the attribute, name of relation, anything, even you can create the name of a foreign key. Okay, should be meaningful. Some of the project manager provide very strict naming rule. And also, some of the company has a global naming rule. For example, when I worked for the bank, so that bank has the naming rule like the 1, 2, 3, 4 surface of the name of the database. For example, online service is the always 3, ACC. It's account. It's account. And the balance, EAN, 3 letter. Then first one is I indicate the internet banking. And the B is the data warehousing, something like that. Okay? So there and always underscore, then details of description. This one should be less than 10 characters. Like that. This is the kind of the naming rule you should follow. So here, so you can, however, if you use the D number, so it's sometimes confused. So but we can use the later we will see the naming rule of the relational model, the relation dot attribute. So relation is the project. That the D, if we are using D number, we can use the project dot D number. Okay. Also, we will see that during the sequel there is the schema name. Schema name is the component. So schema name dot the relation name, table name dot you can have the name of the attribute. So when you are doing the project, also please the name meaningful name. Okay. If I cannot understand the meaning of that, so no way. So it is true. Sometimes most of the developers are lazy. So they use the C1 as the column name, C2, C3. So then table name T1, T2, T3. So you should be deducted if you are using such a meaningless name of that. So it is okay, but it is better to differentiate as long as it has a meaningful. Naming rule is really the kind of depending on the project. Okay? There is no general rule, but usually we use the capital letter for the name of the relation or table, and the capital letter for the first one for the attribute. But it depends, of course. Okay, go back to our topic. So our goal is, one more time, from ER diagram to create the relational schema diagram. So take a look at this, and we are going to follow the step by step. The first thing, so we are going to handle the first step. One, the entity. So entity in EI diagram will be relational model. What is it? It's a table. Okay, so that is one of the reasons ER diagram and the relational schema diagram, they are very similar. So for example here, we have the employee. So employee can be employee relation. We can use the same name, and also what else? Department. And also project. So we have the project. Not weak entity yet. So we will deal with the entity which means strong entity. So we can easily create the relation for the entity. With what? Attribute. So key attribute will be primary key. Because at least one the key attribute for strong entity. Then other attribute will be the attribute of the relation. But this time, when you select the primary key, only one primary key. This one can be the keys, multiple keys, but as we discussed last time, we need to select the one key as the primary key. How can we decide? We need to check requirement. Okay. What application? So if the database requirement is for the student advising, you'd better select the UBID, not social security number. Especially in the college, not all students have the social security number. But if you are building the payroll database, so definitely you need to use the social security number as the primary. So in this case, so we have only social security number as the primary key. So primary key should be underlined. And the other address and the salary, sex. What about the name? So name is the F name, middle name initial, last name. So it's kind of the composite attribute. So can we create like the name and this one? No, relational database model does not allow such a composite attribute, because if you remember, the one of the constraint of the relational model is atomic value. It should be atomic. So you need to decide whether name, or if you check your application, your requirement need first name, middle name initial, last name. Separately, you can use the subcomponent of the composite attribute. Okay, either way, you need to select one or the subcomponent of it. Okay, you cannot create the composite attribute in a relation. Should be atomic, atomic, atomic. Similarly, we are going to create the department, which can be the primary key, name or number. Which one is better? Number might be better. First, because the other use the number also, right? And also, number and the text. D name is the text. Which one will be faster to process? Definitely, number is faster. After we when we are searching the data, so if we have such a number, so we can create the number, but as I said, it's a meaningful name. So let's create the D number as the primary key. And the other D name can be candidate key. So to represent the candidate key, we can use the dot line like that. So D name can be the candidate key. Then locations. What is the double over in it's a multi-valued one? Is it allowed in the relational database? Multi-value? Definitely not. So we are going to handle later. So such a multi-value. What about the project? Project name and the number. Which one may be better? So number is a P number as the primary key, and P name is the candidate key. And we have a location. One location is okay. It's a single value. Okay, this is a first step. So always we can create the table and the attribute. But you should be careful, attribute should be atomic. Okay, then second step is the relationship. So we have different types of relationship. One to one, one to many, many to many. So let's handle the easier one. Easiest one is one to many. In case of one to many, what is the one to many? In this case, one to many. And which means, so employee works for department, right? So which means employee should have the information about the department, right? What kind of information? If we know the D number, because it's a primary key, we can check the department information where each employee is working for. So which means, so to create the relational schema diagram for one to many, we can create one foreign key. But careful, which one is the starting and which one will be ending? Many side is the starting. For each employee works for the one side. You should know the one department. So always confusing, really. So please, the many side you can start. For example, we can create either D NO or D number, employee, then this one, left for what? then we are able to get the information about the department from using DM. Okay? This is a foreign key, so you can create a foreign key. Any other? So we can have the one-to-many department to the project. Department to the project. Department, which one is a many-sided project, which means we need the D number. Okay? This is a controlling department, so we can create foreign key like this. Anyone else? Anything else? This one is the weak entity we will take care later. But what about this one? One-to-many. Supervisor employee is supervised by another employee. Right? So another employee is the supervisor. So we need to have the supervisor SSN. But how can I get the information about the supervisor employee? Using this one. Okay? So this is the many side and one side. Many employee is supervising. The supervised by the supervisor employee. So this one is the self-reference, the foreign key. So you can create the foreign key for the same table, same relation. Okay, anything else? One-to-many? I think that pretty much we took care of. Okay. Then, next one is one-to-one. One-to-one is a really interesting one. Okay, so for example, we have one-to-one employee and the department. This is the manager. If you see the one-to-one mapping, it's like this one in terms of the diagram in your math class. That means if for one-to-one, why not combine so this one may have a Lee, this one is a CS. Why not have Lee, CS combined? Because it's a one-to-one mapping, right? So when you have one-to-one the mapping, you can first merge it into one relation. You can create the one relation from the two entities. You can combine this one and this. Okay? If there are any attribute like the start date, so you can add the start date here. So one, the merge the attribute. Okay? So this is the first option. Second option is you can move. The problem is that this attribute. You can move this attribute to the either E side or department side. So if you have the attribute start date, you can add the start date as comma start date or Lee comma start date. Then create the two tables. So you can create the two relation. Then move attribute to the one of the relation. So for example, in this case, so we can create the employee. We can create the employee SSN and also we can create the department. So D number. Then we can create the start date here or start date here. Either of them. Which one will be better? This one or this one? At this time, this one will be better. Why? Not all employees are the manager. So if you create the start date here, still okay, but a lot of employees, they do not have a starting date of the manager. Okay? So this one it has should have the start date for each manager of the department. So you can create such the two relations for the one-to-one map. Then third option is, when you have the one-to-one, why don't you create the one relation for one table for the relationship plus two relation plus two foreign key. Meaning is, so in this case, we create the employee and we create the department and we create the manager information. Then this one is SSN, this one is DNO, D number, primary key. Then when you create the manager, primary key is SSN plus D number is a composite. Then create the foreign key. Then start date will be here. So you can create the one in between relation, then connect them using foreign key. So first, when do we need to select the third option? When? Depending on requirement. So for example, a lot of application, a lot of query would like to access manager information. Okay? So at the time, you do better because the department has not only manager information but all department information. So if you have the specific menu, application, or query, select the data only for manager information, start date, end date, or the salary of the manager, or the evaluation of the manager. If you have the such option, you do better separate. Create this table. Okay? Then connect the employee and connect the department like this. So one of these options. In this case, because the manager information is not very detailed. Also, we cannot select the first option in our case because we have the workforce. That's separate. That separate the employee and department. So in this case, we are going to select the second option, which means we have the start date here and manager social security number. Then create the foreign key. I forgot to mention about the move to then the plus one foreign key. Like this. Okay. So in case of the relationship, there are three different types of relationship. So one-to-one, one-to-many, many-to-many. In case of one-to-many, you can just create a foreign key. In case of one-to-one, there are three options. So merge, and this one is the most popular one. Most of case, you can create the foreign key. Okay, then move any attribute to the proper side. This option can be doable if you have a lot of separate information about that relationship. Okay, so this one. Then many-to-many. So we have the many-to-many case here. Employee works on the specific project. So first, you need to understand what is the many-to-many. Many-to-many means, so for example, in this case, Lee works on project 1. How many hours? 10 hours. Lee works on project 2. How many hours? 20 hours. So also, James works on project 1 without Lee. Okay? How many hours? 25 hours. So in that case, hours cannot be part of the employee. Hours cannot be part of the project because multiple value. So from the employee side, Lee works on project 1, project 2, project 3. And the project side, the project 1 has the Lee, James, Smith, like that. So we cannot actually move this hours either of them. So in case of many-to-many, we are going to do the exactly same approach as the third option of the one-to-one. So create the one relation, okay, in between for the relationship, plus create the two foreign key, plus create the attribute. What about the primary key? Primary key is the combination of the primary key of employee, primary key of project. So in this case, if we create the work on first the primary key, employee SSN, plus the project P num. This is a composite primary key connected. Okay? If you want to make sure it's a composite, you can even use the bracket. Okay? Then, more important thing is hours. You should create the hours attribute. Then, not yet, you need to create this one, and you need to create the P num is here. Okay? Don't be confused the direction, always the direction. Okay? So you need to ensure the direction of that. So that was the reason when you are doing the lab with the Irwin software or any other software, what happens when you create the many-to-many relationship? Some of the tools automatically create a table entity. Or if you right-click, you can propagate. The relationship can be one table with two foreign, like that. So you can, that is because of the such a characteristic of the many-to-many. So when you think about it, when you design many-to-many, many always create the relation table. Okay? Another example of the such a many-to-many is the student register course. The register. It's a many-to-many. Course has many students. One student can take the many. This. So this one eventually will be registration. Right? There are many such a many-to-many cases. Really happen a lot. Because of that, when you design the ER diagram, it's a simple. But when you create the database, there are more the tables. That's true. Okay, that is the first step and the second step, the major part. Then, what we miss is this one. Step 3 is a weak entity. So weak entity. So in case of a weak entity, major problem of the weak entity is it doesn't have the key, only partial key. So we need to use identifying relationship to identify the dependent. So we need to get the social security number plus name, then it's finally the primary. So with entity we can create the relation plus primary key is the composite with the identify the entity with the primary key of the relation, other relation. Plus, we can create the foreign key. That the key should exist in the employee. One foreign key. So let's see the example. So we can have the dependent. We can have the dependent with the name is not the primary key. We need to borrow the SSN to differentiate. You can put the E or the even SSN is fine. So this is the composite primary key connected. Then other attribute like the sex, DOB, and relationship. This is the entity for the dependent. Not done yet. ESSN should exist the SSN. Okay? So this is the third step. The third step of the mapping from ER to ER is like this. And what about the location, multi-valued? The multi-valued, the attribute. Multi-valued attribute, the problem of the multi-valued is the relational database model cannot handle multi-valued. So how can we? We need to create a separate table relation. So create the new relation plus foreign key. So for example, here we are going to create the department with the location. Department location with. When we create this one, so what is the primary key? So the number, but the different location. So we should have the name of the location, the LOC name. If there are more information like the address or the price or the manager, you can put over here. But in our case, we don't. So this will be primary key. So for example, the number 1 has the LA. The number 1 also New York office, like this, multiple location. So it's not done yet. We need to create the foreign key. This D number should exist the D number. However, this location is a single value. It's normal. So it's just the project is a location. So many students confuse why this location is the attribute, why this one is the separate the relation. Because of this one, this reason, relational database cannot have a multi-value. Because of that, when you design the relational database, there are really a lot of small tables. So small table, like the department location. Sometimes this kind of the table is called the lookup table. Lookup table. 1 means CS, 2 means the something like that. What if you have the multiple major? So major can be multi-valued. So you can have such a separate table. And also, this one is called sometimes code table. Interpret the code like that. So this is a multi-value. So step 4 is a multi-value. Any other? So we already did one-to-one, one-to-many, many-to-many, multi-valued. Oh, the N array. So I think that this one is pretty much done for our cases. So let's compare with this one. Employee has the employee. DNO refer the D number, and the super SSN refer the SSN, like that. And department location, D number refer the this one, and the project is here, and then the work zone is here, dependent is here. Okay, so this is the result of converting ER diagram to our relational database schema diagram. Question?
Sir, for that weak entity dependence to employee, there is one foreign key, right, sir?
The weak entity dependent to ESSN.
SSN to employee.
Employee SSN.
So, does that mean we do have multiple MEs to 1 ratio, or?
This question is, so when we the foreign key usually refer one-to-many relationship. Think about this relationship before. Even though we named as identifying relationship, if we just consider one-to-many relationship, one employee has many dependents.
But here many.
You can have the many. For example, my SSN is 111. Then I have the Nicholas as a dependent, my son. 111 has my daughter is Unji is I can have the multiple the dependent. Right? So it's the same as the one-to-many relationship. Even though we named the different way, so this is result of this one. So pretty much we covered the most of the case. So what we miss is the NRA relationship. For example, supplier supply the project with a specific item. So supply. It's the ternary relationship. Three entities are involved. Ternary relationship. So in that case, how can we address? If you remember the ternary relationship before, actually there are different ways to represent this ternary relationship. One of the way is we can create this one. In the one entity for the ternary relationship, supplier, okay? And the supplier, part of, and the project, part of, item, part of. At that time, what will be the key of this one? Surrogate key. Do you remember artificial key? Key of this, key of this, key of this. If we convert this ternary relationship with the binary relationship, then we can apply this one. We can apply this one-to-many relationship. Okay, so let's quickly look at the example of such a ternary relationship. So supplier supply the project and the specific part. This is a part. Then, so we'd better have something attribute for the supply ternary relationship quantity. How many? So at the time we can convert this one into the supply, the entity, and create the three binary relationships. So this one will be like this. We have a supplier, S name is a primary key, project name is a primary key of project, part number is the primary key of part. At the time, primary key of supply is this. Primary key of this one is S name plus the project name or part number. It's the composite primary key, but should be connected. It should be connected. It's one primary key. But each of them should refer each one. As I said, this one is not exactly same as what we intended. Okay? Because there might be parts which are not actually supplied. Okay? It may be possible because we separate binary. But there is no way to create the ternary relationship with a relational schema diagram. Relational schema diagram only allows two participation, binary relationship. Then with the foreign key. Only foreign key is starting end. So no way to represent this one. So we convert this and relational schema diagram. So this is an NRA relationship. So this is a summary of the ER model and relational model. Entity is the relation table. One-to-one or one-to-many, we can create the foreign key. In case of one-to-one, there are other options not frequently used. Mostly, the one foreign key is popular. Many-to-many, we create the one relation and two foreign key. NRA, so we can do this one. And simple attribute, just a column and the composite, and we need to decide whether one or separate. Then multi-valued is the tricky. We need to create the relation with the foreign key. Actually, domain is not implemented, so I'm not going to explain the domain. Key attribute, you need to select the one primary key with secondary means candidate key. Okay? You can have the multiple secondary, multiple candidate. So if you have the secondary, you can using the dot line. Okay? Any question? This is very straightforward. So it's just one or two times practice, you can do that. So, continuing the homework, the last time that you did the homework, I'm not sure, anyone who wrote your homework? So online, the bookstore. Anyone online book? Yes. So you did the homework over here. So using the other side. So your ER diagram, following this step, following the step, so why don't you draw the relational schema diagram on the other side. If you lose, please use another scratch paper, but you don't have to spend a lot of time to fancy nice the diagram using software, just the handwriting is okay. So by the Wednesday, so it takes just 10 minutes just for your practice. Definitely I'm going to ask the same style question from your submission, but I little bit disappointed your submissions, so I actually mail out to you. So some of the students misunderstood or missed the item, like just to submit the EI diagram, or some of the students just to submit the requirement only without the EI diagram. Also, couple of students create the really simple one student actually submit the entity, and one student submit the 3 entity. So please think about the 4 or 5. So if you wanna resubmit, I think I mostly give just 10 points. It's the maximum, but some of the students received less than 10. If you wanna catch up or the makeup, you can resubmit, because I'm going to select one of your submission for the midterm exam. Okay, so who knows, you can be. That is almost 60% of the midterm exam. So one part is the ER diagram, and one part is the relational schema diagram. The next part is the data definition language to create the database based on the relational schema diagram. Last one will be select, how to select. So if your database is selected, so it's much better. Also, you guys can study for the midterm exam with that. I think I already emailed out, right? Send a Canvas message. But if you want to resubmit, please directly email the Canvas message to me by the end of this week, the Friday. Then will be reconsidered. Also, some of the students didn't submit. Please, I will give the chance. Okay, so that is a mapping, but not done yet. So not done yet. So we have the EER part. So for your reminder, ER and enhanced ER is the super and subclasses, the relationship like this, right? So how many entities? This is just one entity, okay? But it has a subclass like the employee and the technician and the secretary and the engineer, like this. We have the social security number and the other attribute that can be automatically inherited to the subclass. Also, each subclass may have their own attributes. So we try to address this one to create the relational schema diagram. So it's very straightforward. Let's consider the example of this one. So we have employee. I'm not going to draw it again. There are different options. So first option is create how many entities here? 1. So how many tables we can create? First option is 1. That is not. That is the last option. So let's start. Okay, how many classes? 1 superclass and 3 subclasses. So can we create the one table for each class? Even though it's one entity does not mean the one relation yet. Okay? So first option is one relation for one class for each class. Meaning is we can create the employee relation table. So what is the primary key of employee superclass? SSN. Then we are going to create the first name, middle name, initial, last name. Then what else? The birthday, DOB, date of birth, address, and the job time. Then secretary can be 1. What is the primary key of SSN? Because it's inherited. What about the F name, middle name, initial, last name, DOB, address, and job type? Do I need to create? Instead, we can create the foreign key to this one. Then, using the SSN, we can find all details of information about employee. However, we have the typing speed attribute like this, and the T grade. Not T grade. The technician. Same thing. SSN is the primary key. Then the T grade. Then we can find detailed information about the technician. The third one is engineer. SSN and the engineer type. Like this. So first option is we can create the one relation, one table per each class. If you have a multiple superclass, separate. So one for each in this case. However, don't forget to create the foreign key. Otherwise, you need to put all the information. Okay? It will be duplicate, redundant information. Okay, so this is the first option. Option 2 is the one relation for only subclass. So without creating the employee, we can create the secretary. SSN. And then we have typing speed. That's it. We need to put all the information inherit. Because we are not going to create the superclass relation. So attribute of the superclass, like the first name, middle name, initial, last name, will be created. And DOB, address, job time. Then the technician is the same. SSN and the T grade, and first name, middle name, initial, last name, and DOB, and address, and job type. And the technician and the engineer. SSN, this is the engineer type, first name, middle name, initial, last name, and DOB, and address, and job type. Do I need to create the foreign key here? We don't have to. They are separate. Each of them is the independent relation table. So you don't have to create the foreign key. What is the difference between the option 1 and option 2?
That's the generalization.
Yes. So if you generalize into the employee, okay, then we can manage the generalization. In case of generalization like this, you first identify secretary, technician, engineer, right? So if generalized information not very important in your application, okay, these are not very important and very simple. then we don't have to, they are not much related. Also, for example, we are going to build a secretary database. We are going to build a technician database. We are going to build the engineer, the application database. We don't have to generalize into this one. So we can select this option. However, like the specialization, you identify employee and specialize into this one. Then at that time, you'd better select this option. Also, even though generalization, when you generalize into the employee, this employee is really important, the information data. So it should be generalized and specialized like this. So you can select the option 1. So it depends on your requirement also. So either option 1 and option 2. Okay? If they are related and you are frequently access such the common data, you do better. Like also, in case of overlap, which one will be better? Option 1 is better because overlap, if you select this one, same information everywhere. It's very hard to manage. At the time, you better select this one. So next class, we have a couple of more options for the EER. Oh, we have 4 more minutes. Quickly go over. So option 3 and 4 is eventually we are going to, how many entities here? It's an employee. So why don't we create the one relationship? SSN and the job, the first name, middle name initial, last name, and DOB, and the address, job type, like this. Then, to keep this subclass information, so we are going to check whether secretary, yes or no. It's a Boolean type. And the technician, yes or no. It's a Boolean, true or false. And engineer, yes or no. Then we can create the secretary typing speed. And we can create the engineer, technician T grade. And the engineer, NENG type. So we can check whether subclass or not. Subclass or not. Then add the such an attribute. The option 4 is similar. SSN, first name, middle name initial, last name, and DOB, address, and job type. We can put typing speed, T grade, engineer, type. The difference between the option 3 and 4 is, so for example, 111, the J, the K, Lee, blah blah blah. Job type is the secretary and technician. My job type is secretary and technician. Then secretary, yes. Typing speed 100. Technician, yes. T grade is the high experience. And engineer, no. So none. Like this. Okay. Another example, 112. We can put the such information. Yes. 200. No. None. No. None. Like this. This one, for example, 111. First name, the J, K, Lee, and DOB, and the address job type is the secretary. Then typing speed 100. T grade? What? Okay, none, for example. None. The difference between this one and this one is, this one usually take the overlap. Because you can check yes or no, yes or no, yes or no. However, in this case, the option 4, you need to specify the specific job type. Either one of these. Even though you put the value, you are not sure. In your application, you need to check. So, option 3, use the one table with Boolean of each of the subclass. Option 4, create the one table, but it doesn't ask whether this one belongs to the specific subclass or not. Mostly, this one is used for overlap case. This one is used for disjoint. Okay. Otherwise, you need to specify all the different combination of job type. Okay. So we have the 4 different cases. So in the conceptual level design, think about if you have the super and sub, I suggest requirement to create the intention and create the super and subclasses relationship. At the time, think about which option will be the feasible, considering your requirement. Okay, so this is the last step of the converting ER diagram to the our relational schema diagram. So we will see a couple of my example the next class. Then we will continue for the relational calculus, relational algebra. Okay, which is the foundation of the fundamental of the SQL. Any questions? The homework, you will practice more about this one. From the homework assignment, from the canvas. Okay, we will see a couple of my examples in the next class and continue for the relational algebra and calculus. Okay, thank you.